Methods, this is where, right? So the easy ones are things like product measures, pre-test, post-test, transfer, if we're doing immediate transfer, delayed transfer, quizzes, summaries. And then, so what we try to do is the different data types, the different methods or tools, and then what kind of data would they give us? Did they give us data about metacognition, cognition, emotions, or motivation? Okay? So of course, if I am interested in cognitive metacognitive, well, the concurrent think aloud protocols, like verbalization that young lady was doing in the first video, is the best, right? Log file data, which a lot of our colleagues use, okay, and we use that too. That's at the millisecond. We know exactly, so in a 2-hour session of MetaTutor, it may generate 30 to 40 pages single space. That's how fine level detailed it is. So you can ask the question, well, how much time did a student spend on text versus diagrams in general, or on a particular page, or what is the sequence that they followed? And is that why they didn't do well on my test or quiz? Okay. So what we're interested in, and I'm going to show you, is some of what we call the process data, which is very time consuming. So we can have physiological measures such as electrodermal activity or GSR, right, or EEG. Of course, those tell us a little bit about cognition, but a lot more about emotions. Okay, and then the yellow basically means that sometimes, even though concurrent think aloud protocols, for example, are the ideal tool to give us data about cognitive metacognitive, sometimes students slip. And that's why the yellow is there. They'll say, I really hate SAM. Okay, well, that means a lot of emotions, okay? Or this task, I find no value in doing this, okay? All right? So we try to use this, and a lot of our colleagues use self-report measures, which, we're fine with, because these are easy to administer, as you all know, right? But the question is, we have a problem with self-report measures in that they tell us about students' perceptions of who they are as learners. They don't tell us what they actually do when they're learning. This is why we focus on the process data. Okay? And in fact, many of the recent studies, when we correlate process data with self-report data, it's completely miscalibrated. Okay? Because on paper, yeah, they're all the best learners. Sure, I ask my instructor for help all the time, right? I engage in help seeking, and it's always adaptive. Really? Not so much. Okay? Typical setup, okay, and this is in the laboratory, but you can actually do this anywhere. It can be at home, it can be in an informal setting like a coffee shop, etc. Okay, so we have cameras where we look at the emotions that are detected. We have the eye tracker. Of course, this is one of the things that obviously would be, unless we have a lot of money, it'd be hard to do eye trackers. These are about $40,000 each. Okay, they're now gone down to 100 and 500. So we're trying to test the quality of those, because then you can actually have one. Every kid could have one. Right, so the eye tracking, the dialogue, the self-regulation palette, and then the screen capture. So we use Camtasia. So we also have a video clip of exactly what they did and when they did it. This is the notepad I was telling you about. That's USB connected. Okay, so in the log file, it doesn't obviously, they write and draw here if they want to, but all we see in the log file is the pen is sensitive, so it's just pen down, what time that happened, pen up. So if you actually want to look at the content, we still have to examine their notes. Okay. The GSR bracelet, so for the electrodermal activity, okay, spikes in arousal, and then the concurrent think aloud protocol, if we wanted. So the only two things that are prohibitive, of course, in a classroom, obviously, would be the eye tracking and the concurrent think aloud protocol. It'd be pretty noisy, having 30 or 20 kids talk at the same time. And of course, then there are also some issues with ethics and some institutions like Wake County. For example, with the middle school kids and high school kids, we can't collect GSR data. So we bypass that by having an IRB from the NC State and having the kids come to the lab with their parents, and that's okay. So this is a typical setup. So imagine collecting all these data types in real time and then trying to make sense of them. Without going into much detail, this is the trace data. So we want to figure out, using machine learning and data mining techniques, so for example, if this is the eye tracking data, okay, sometimes there are gaps because the student may be looking down, so that means the eye tracker is not looking at you, the infrared, okay. The other one could be the log file data, the other could be facial expressions. We're trying to figure out, are there particular data channels that are predictive of, we find out that students at some point in time are actually setting good quality sub-goals, learning goals, not quantity only, okay? Versus a mental model shift they've gone from a very naive understanding of the circulatory system, where it's only, for example, one pump, to the highest level, which is actually a dual pump, right, with a respiratory system. When does that actually happen? So we're trying to figure out, using these data channels, okay, to figure out when those shifts occur, okay? Or from a motivation, this is probably one of the most difficult and challenging for researchers and educators, is trying to figure out when does a student feel self-efficacious about using high-level strategies. Like, now I feel very comfortable about making hypotheses, okay, or making an inference, okay, because that's also something that's confusing. So they sometimes understand, what's the difference between a hypothesis and an inference? Okay, even with grad students, I had that talk with my first year grad students. Okay, what you wrote is not a good research question, and it's not testable hypotheses. Okay, so we're trying to figure out from the data when we can. The stuff that's easy is this, right? Imagine you have a pretest, so you have declarative knowledge or factual knowledge about a body system, right? How it works and perhaps malfunctions. So I'm going to give that as part of prior to the pretest, okay? And I'm going to administer again at post-test. Well, that's kind of an no-brainer, right? But it's that trace data, the real-time dynamics that we're really interested in to, of course, augment some of the other data that we have. Put another way, this is what it looks like. Are there, for example, fluctuations in facial expressions? Okay, somebody go from angry to, confused, frustrated, neutral, which we're still debating whether neutral is an actual emotion. Okay, it's like, okay, let's leave that one alone. All right, and eye tracking data. So, for example, this is what a typical page from a log file looks like. So, just to show you some of the data. Okay, so at the millisecond, we know exactly what rule was fired by the agent, by the system, okay, how much time they spent reading. They spent 41 pages reading. They spent X amount of time, reading page 41. Okay, we know what page 41 is, etc. So what differences can we make about navigation and learning, okay? These are some of the things that we could do. Here's some more of the interesting things. So we can look at basic emotions. So we work with folks who developed this. This is called Face Reader. It creates a wire mesh for each student, okay, and looks at their basic emotions in real time, so we can detect it in real time. But what we're interested in actually is more the learner-centered emotions, okay? So neutral is a little quirky. We like to see a little more happiness when they're reading about science, okay? That would be a really good thing. And the agent could just take a break and go on vacation, right? But things like boredom, right? Why are they bored, and what do we do about a student who shows that he or she is bored, okay? Do we relate the fact that learning this content is really important for what they want to do, okay?
We make the agent dance.
Oh, that would be great. Spin on its head. Mm-hmm. Confusion is a big one, okay? Confusion, because the issue is that we've noticed is that if you don't take care of confusion, confusion will transition into frustration. You don't take care of frustration, you got complete cognitive disengagement, and then you've just lost a student. So the question is, let's track that, and the question is, what do we do about it? When do we intervene? And when we intervene, what do we do for the student? Okay. We've also noticed contempt. Some of the high ability students have shown contempt, which is kind of a complex emotion, and it's usually when the agent is saying something, it's like, yeah, I'm just gonna not listen to you, kind of thing. It's like, yeah. So most of the time, as we are finding and digging into the data, is that they're very, of course, they came in with high prior knowledge, so they know, it's like, just back off. I don't need you. Thanks. Okay.
For the facial recognition, does it have to be calibrated every time the student sits down, or is it kind of built in seamlessly?
It's calibrated initially. It takes about a minute. Right? Creates a model for each student, and then it just runs continuously.
Do you give them a task, or how do you get the baseline?
The baseline is just basically staring at a screen, just like we do with eye tracking. So basically, we just give them the crosshairs, and they just stare at it, so we can get the baseline pupil dilation. Yeah.
So basically, everybody's facial emotions are close enough to match those 6?
Yes, and then of course there are some deviations, and I mean one of the biggest issues we have are things like constraints, right? So for example, sometimes we have people coming in, so it's nice to get a nice big forehead, right? Because we need access to that. So anybody's got low, the Justin Bieber, as we saw a lot of grade 8s last week, the boys, the Justin Bieber haircut, it's like It was hard, because I mean, everything was occluded. Or they come in with baseball caps and we tell them, no, we need, you know, you can't cover your face, you can't have any shadows on your face. So there are certain constraints that we need to take care of. No headscarves, okay, because we need access to the entire face. So those are some of the criteria, and if you don't meet that criteria, then you can't participate, right? The other issue also is with people, of course, humans, especially adults, being better able, through our experience in life, of being able to mask, right, socially acceptable emotions, right? But, you know, given a 2-hour, 3-hour task, they kind of tend to forget about that, right? The other thing that we need to do, that we're working with this company in particular, is cultural differences, okay, in terms of difference. So they have a model for Caucasians, for Asians, and they have one for children also, okay, to kind of accommodate. So that's some of the data. And of course, so what I wanted to show you, since we're trying to do my own metacognitive monitoring, one of the things that we are working with a colleague at the University of British Columbia, a computer scientist, is can we detect, going back to eye tracking, can we detect with a certain level of accuracy, okay, whether a student is engaged or disengaged based on the eye tracking, the gaze behavior of the interface, okay? So some of the preliminary data we presented this past summer at a conference is that the engaged student will look at the overall learning goal, then inspect, okay, the table of contents, all right? And if they start with a diagram, okay, they tend to triangulate the diagram. So they're trying to do some kind of coordination of informational sources. There's an arrow here missing, and going back to the overall learning goal, okay, which kind of makes sense. So imagine that now the next version of the adaptive system is, this is robust, let's say even with 70%, which is asking a lot from machine learning, okay? It's pretty good. So imagine being able to detect this, and if you are detecting that and we classify that as engaged, then, you know, do we do something different than the student who's disengaged? Okay, when they're disengaged, I mean, they spend a lot of time, they just fixate on the agent, okay? They fixate on the agent, and then they'll go back and forth. Okay, it's a little bit more erratic, okay? So those are,
If
sorry.
that happens, will the agent then say, why don't you read the learning objective table? Will it direct them through that
Yeah,
triangulation?
so that'll be the next step, yeah. So if these are robust, can we detect these in real time, and then be more specific, like you're saying, with the message that you give the student? Yeah. And then we can do other things like configure, you know, their navigation profile. Here's a student who went through the content. These are the pages plus one. So they went very linearly through the content, they went back to previous content, they went linearly again, back down, and then they basically did all the content in a very linear way, except for, and so the question is, this is interesting because you can see the navigational path, but this doesn't tell us what happened here, right? Was there some kind of metacognitive process that led you to go back to a previously seen page? So those are the kinds of questions that we can start asking. Versus a student here that we like to call the schizophrenic student. It's all over the place, right? But from a learning perspective, that's the student who actually did best from pre to post compared to this person. So imagine from a systems perspective and an AI system, we're trying to, this is easy to model, because I'm just watching you, you're going linearly, right? Not so much, okay?
Is that student that didn't go linearly, they're more engaged with the material, aren't they? Because
Yeah.
they're looking and.
They're looking.
And searching and trying to find the information.
Yeah. And then they also provide more or richer data in terms of their cognitive metacognitive processes. And hopefully they're, you know, that's the other thing, is looking at their facial expressions will be different than this person here. Okay? So those are some of the, so just to give you also, since we're about running out of time, wanted to give you a flavor for when we, so right now these are just static representations of the data. But to give you a full flavor for what the data actually looks like and how complex it is, here's a video of a student, and this is where we start talking about converging multiple data channels. Okay. So this is a good self-regulator.
Let's set up some simple.
So you see their eye tracking behavior. We have the screenshot.
About diseases of what?
Great. Did you want to learn about malfunctions of the circulatory system?
Yeah.
Wonderful.
So
We
this-
just set up a good example.
So now he's searching.
Okay, yeah, let's look at liver diseases, circulatory circulatory system diseases, this looks like it'd be related to malfunctions of
There
the
is,
circulatory
goes,
system.
goes again, so making a judge.
Hemophilia. Okay. Hemophilia is a bleeding disorder that results from a genetic deficiency in the coagulation pathways causing uncontrollable bleeding. First, I should note that this is relevant.
Do you think this page and image are relevant and appropriate to your current sub-goal of learning about malfunctions of the circulatory system?
Yeah, this is relevant, and so is the picture. Both are
Great,
relevant.
I agree. Why don't we go ahead and read this page and be sure to use some good learning strategies and monitor your understanding.
Yeah,
So this,
start
you know,
by-
just to show you the complexity, so you can see, so we can look at their facial expressions, we can see what he's doing, what he's fixating on,
So,
right,
you know,
when he's reading,
hemophilia is blood
and
disorder.
interaction from the agents. And that's just with 3 data channels, okay, so we have plenty more. So the question becomes, what is the best constellation for whatever question we're trying to address?
It's related to uncontrolled.
Just like, so we're working with a new company called iMotions, and so here's a student, yes, very cheery. So she's reading some content about the structure of an atom, and what we're gonna show you is basically, you're gonna see a rectangle, and that's for the accuracy of the facial expressions, and almost like an EKG, basically, here's, you know, anger, surprise, etc., contempt, and you can see the fluctuation in facial expressions. And then you're also gonna see the eye tracking data, and it's gonna be marked to show you the sequence. That's what she's reading and learning about. Okay. So in what, 2 seconds? That's how much data is produced, especially from the eye tracking. Right? So we're trying to figure out where, well, we can actually see what her gaze behavior pattern was. Okay? So it may be that she doesn't understand or didn't understand this correctly because she failed to figure out that, you know, the key content was here. Okay? So we can do these kinds of things. Where are you? So this is just some other way of doing it. Do pupil dilation. I got a student who's interested in cognitive load. So looking at pupil dilation as a measure of cognitive load. All right, so if you overload me too cognitively, so the pupil dilation does exceed the threshold, okay, it may be that you are engaging in extraneous cognitive loads, and then after that, basically, you're really pushing my system, and I'm not gonna really learn much, okay? So we would like to see kind of a decrease in fluctuation, so you can do that. This is another one with students, because we allow them to cut and paste their notes, right? So initially, oh, it's first time learning about the circulatory system. So, okay, you may cut and paste into your notes, but there's an instructional question again, right? At what point during the semester, for example, do I now tell you, you know, you've been taking basically verbatim notes or copying notes, now I want you to start paraphrasing or summarizing it on your own. When does that happen? You know, when do we tell students that, okay? So we can do that with the student. And then just finishing off, so all this to say basically also for the last year and a half, we've been trying to do some collaborations with other colleagues. So everything from games, so this is James Lester stuff, Crystal Island for STEM, which is our co-PI along with Candace and I for our project. We've been working with colleagues at Duke in terms of mannequins, high fidelity mannequins, and also serious games for anesthesiology. Basically trying to figure out how better to train anesthesiology residents. And also with another colleague in computer science, Michael Young, and some forensic scientists who actually, when there is an actual crime committed, it's called IC Crime Project. So a crime is committed in our area here, the team goes in and does full-scale scanning of the entire scenes, recreates the scenes, and basically teach forensic scientists how to collect evidence and how to manipulate evidence and communicate. And this is one of the ones, we're still trying to do this here, but this is part of McGill. And this is now going beyond individual learning, this is group learning, where we're looking at emotions in a group setting. So this is still from McGill, one of the medical simulation centers. So we've got a high fidelity mannequin. We are standing behind a one-way mirror with all the physicians who created the case. This is a case of pulmonary embolism in a pregnant woman. So there's a team of residents outside, they're all wearing GSR. Okay, so we want to look at their level of arousal, and we also have cameras to look at verbal, nonverbal behavior. And the question is, they have 10 minutes to save the woman and the baby. Okay, so we're really trying to figure out is how does the team leader monitor his or her own emotions and the team's emotions, okay, without having a breakdown in terms and leading to obviously killing the mom and the baby, okay, which most of the time they do. And then sometimes we put in a person who helps him. This guy is actually a pediatric nurse, who will help, but sometimes he doesn't help actually. He interferes with their reasoning. So here's the team leader, the third-year resident. These are usually first-year and second-year residents. And if they're doing really well, what we'll do is the physicians behind the scene will actually ask the computer programmer to drop, let's say, the blood pressure or make some kind of critical event, or they need more blood. And of course, there's no typing, so they're gonna have to wait 2-3 hours. They don't have 2-3 hours, so they're gonna go with what they have. Okay. And we see how far we can push them to the brink of actually interfering with their ability to engage with the muscle. So that's some of the work that we've been doing. In terms of the classroom also, this is another grant that we have that's been submitted, is trying to take this traditional classroom. So imagine, and this, this is with kids because we submitted with the high school and middle school teachers, but this can be in any classroom. So here's a traditional classroom, the good old boring whiteboard, right? You've got a teacher, these kids are working on some environment, but imagine replacing that. So this gets to the learner analytics and teacher analytics. Right, so everybody keeps talking about learner analytics, but what about teacher analytics? What data, for example, of the ones that I showed you as a sample, would you use, right, to make instructional decisions if we were able to collect them in real time? So imagine a future classroom.
Nice Photoshop job.
Thanks. And she dyed her hair differently. Yes, all in one swoop. So imagine a kid using, let's say, MetaTutor, okay? And imagine the system being adaptive in real time to address each individual student's individual needs. But at the same time, the data is being collected and presented to a teacher dashboard in real time. So, but it becomes a question of, so the facial expression data, how would we re-represent that facial expression data for a faculty, for a teacher, to make sense for him or her, right? Because we also want the teacher, imagine being instrumented with an EKG and eye tracker, right? Does the teacher actually pay attention to the data? For example, let's say it's facial data. Does he or she pay attention to facial data, which is related to their students' emotions? And then if she or he does, then how does that translate into instructional decision making in real time? Right, so kind of integration of learner and teacher analytics. So that's something that we're doing, and lots of other projects. But this can't be done without a team of excellent students and postdocs. And I need to revise this and put Candace's name here. And colleagues from different disciplines, from medicine to computer science and electrical engineering and STEM. That make our life really wonderful to work with.